From the first identity, sine squared theta plus cosine squared theta equals to 1. If I divide everything by cosine squared theta, divide by cosine squared theta, divide by cosine squared theta, what you're going to obtain is sine theta over cosine theta, the whole thing squared, plus 1 equals to 1 minus cosine theta, the whole thing squared. Now on the side, I know that tangent theta equals to sine theta, sine theta over cosine theta, and I know that secant theta equals to 1 over cosine theta. That means I can replace these two brackets and obtain the identity on the left, which is tangent square theta plus 1 is equals to secant square theta. Now, of course, I can take this and rearrange it and obtain another identity, which is essentially the same thing but rearranged form, right? That means I can express tangent square theta in terms of secant square theta and secant square theta in terms of tangent square theta. That gives us a way to simplify certain trig equations and expressions. For example, if I ask you to simplify, let's say cosine squared theta times by secant squared theta minus 1. Well, one look at this, I know what secant squared theta minus 1 is tangent squared theta. So I know that I can rewrite this as cosine squared theta times by tangent squared theta. But we're not through yet because tangent squared theta can be written as sine squared theta over cosine squared theta. Okay, so in things like this, you can always further simplify the tangent. Check if you can. All right. So once we express this as fraction, cosine and cosine will cancel out, leaving you with just sine squared theta.